Hi viewers, welcome back to our YouTube channel SHOBHAN'S Math Corner. Through this YouTube channel, I am explaining the math concepts from 8th to 12th standard. So up to 12th standard, all the math basics and advanced also I am going to explain. These are very helpful to the students in their academics. Not only in academy, it is also very helpful for competitive exams like national NDA, national level public service commission, and all state public service commissions. So for all these it is very helpful. So all of you must subscribe this channel for latest videos, and you can share with your friends to whom it is very helpful. Okay, now today through this video we are going to discuss set theory. Sets. What is a set? Set is a collection of well-defined objects. Set is a collection of well-defined objects. That is the definition. What is this well-defined here? Well-defined objects means if you take some group of objects, it is called a set. Sets are denoted by capital letters like A, B, C. And the objects which are in the set are denoted by small letters, and we put this in this bracket called braces, and this may have some numbers also like 1, 2, 3, 4, 5. Here this set, if you see, A is equal to A, E, I, O, U. These are the objects of the set, which are also called elements of the set. Now let us come back to the definition. Set is a collection of well-defined objects. Here if I describe the set A, you see carefully here, you can see A, E, I, O, U. These are the vowels of English alphabet, A, E, I, O, U. So now we are clear about the set A. What is set A? It is a collection of all vowels of English alphabet. So now it is well defined. Well defined in the sense, if I give you some element, you can identify whether the element belongs to the set or not. Like in this we have A, E, I, O, U. If I give you Z, you can say whether Z belongs to this or not. No, Z is not belongs to that. Because if you are very clear, because this set is well defined. Then what is not well defined? If you take some, by using some adverbs like, suppose in your class, good boys. Suppose very good player. Like this. Here, good in the sense, we are not giving any criteria for that. So it is not well defined. So whenever you use good, beautiful, ugly. So for all these, this is not well defined. So well defined means you should be very clear about the element whether that belongs to the set or not. Here in sets we use the symbol epsilon to say whether the element belongs to the set or not. Suppose if I say 1 belongs to B, so 1 is an element of B. Yes, 1 is there in this, so this is true. But if I write 6 here, 6 is not an element of B. So 6 does not belongs to B. 6 does not belongs to B. Okay. So like this, set is a collection of well-defined objects, and sets are denoted by capital letters of English alphabet, and the elements or objects of the set are kept in the bracket called braces. We use these brackets only. Remember, these are called braces, flower brackets, which are called braces. And inside that, the elements are separated with the commas. So the elements may be English alphabet, like numbers, real numbers, can be anything. So that is a collection of well-defined objects, and to show whether the element belongs to the set or not, we use the symbol epsilon, and we read this as 1 belongs to B and 6 does not belongs to B, and Z does not belongs to A for these two sets if you take. Okay, this is the notation of the sets, and to identify whether the element belongs to that or not. Now the representation of sets. We represent the sets in two forms. First one is roster form. Roster form, and second one is set builder form. Builder form. Roster form. Roster form means if you list all the elements of the set, if you write the list of all the elements of the set, that is the roster form. Suppose I am taking A is equal to 2, 4, 6, 8, 10. This is set A. So the same thing, without writing all the elements of the set, if you describe the common property or principle in that. If you see carefully, the numbers 2, 4, 6, 8, 10, all these are even numbers up to 10 or less than or equal to 10 or less than 12. So we write that x such that, we read this as x such that x is an even number. An even number, and we write the property like x is less than or equal to 10. So this is the builder form. In builder form, we describe the property of the set, the common property. What is it that we write? If you list all the elements, that is the roster form. This is the builder form. In roster form, we write all the elements by separating with the commas. Is it possible to write all the sets in the roster form? No, not possible. Suppose if I take a set of rational numbers, you know rational numbers, the numbers which can be expressed in P by Q form, and Q we can write. But if you, writing the list is not possible. If I write like 1 by 2, 1, 0, between 1 by 2 and 1, there are infinitely many numbers, rational numbers. So whenever there are infinite numbers between two elements, it is not possible to write in the roster form. That's why we say this is a Q. Builder form, we can write x such that x is a rational number. We write rational number. We can write in the builder form. But roster form, all sets we cannot express in the roster form. Few sets can be expressed in the roster form. So this is about the builder form and roster form. Roster form means we list all the elements by separating with commas. If you put in the braces bracket, that is the roster form. Builder form, we take the property, common property in that, like by using that x such that x is an even number, odd number, or x is a letter or in English alphabet, oval of English alphabet. Like that we can describe whatever the element set is given. Next we will see types of sets. Null set. Null set means if a set has no elements, that is called null set and denoted by Greek letter phi. Phi is equal to, so this empty bracket means it is a null set. Null set means it has no elements. Suppose if you take one example, in a boys school, the set of girls in a boys school. So if it is a boys school, there will be no girl found. So that is a null set. Like that we can take any set which has no elements. The set which has no elements, that is called the null set and denoted by phi. After that, if you take universal set, universal set is denoted by U or mu also, sometimes is a Greek letter, or U. What is a universal set? So universal set is a set which contains all the elements related to a particular issue. Suppose here we are writing all the sets related to a school. Suppose in school all boys, set B boys, set G all girls. Like in that again we can take cricket players, see all the cricket players of the school. Like that you are taking all the different sets of a school. For these all sets, the universal set is the whole school. So universal set is a school. Means the set which contains all the elements of all sets related to so particular issue. So that's why universal set means is denoted by U or mu. That is the universal set. Now here, as we took universal set, suppose if, as we discussed in a school, the total boy set, girls set, cricket players, badminton players, like that if we take different sets, all these are. I am taking boys, set of boys, all the boys were listing in this, and girls. So these are all part of the universal set. These are the part of universal set. So these are called subsets. Subsets. So what is a subset? Subset means it's part of a universal set. So let us take one example. Suppose A is a set. In this I have the numbers 1, 2, 3, 4, 5, 6, 7, 8. Up to 8 I have. Now I am taking B is another set. In this 2, 4, 6, 8. If you see carefully, all the elements of B are there in A. So here we can say B is a subset of A. B is a subset of A. Here A can be universal set, but if you have any other sets, those elements also should be there in A. Then we can say A is a universal set. Otherwise, just B is subset. The subset symbol is just like this. We will write B is subset to A. B is subset to A means all the elements of B should be there in set A. Then we can say B is subset of A. Here, let us see some important properties about the subset. Here, always we consider phi is subset to all the sets. Whatever the set, phi is subset to all the sets. Means null set is subset to all the sets. This is one property. And every set is subset to itself. Every set is subset to itself. Because every element of B is there in B. So we can say every set is subset to itself. And all the sets are subset to universal set. If there is a universal set, that all the subsets are, these are all the subsets. So this is subset to U. So phi is subset to all the sets. Phi is subset to all the sets, and phi is subset to itself also. And every set is subset to itself, means A is subset to A, and A is subset to U. That is the universal set. This is about the subset. See here one more thing. If B is subset to A, then we can call A as superset to B. A is superset to B. So rarely we use the symbol. If you write in reverse, that is a superset. So B is superset to A. So A is superset to B. So it means B is subset to A. Then we can say A is superset to B. So we find somewhere superset word. Then mostly it is not given. In rare cases they might ask what is a superset. Superset means like universal set only. If A is subset to B, then B is superset to A. This is about the subset and supersets. Now equal sets. What are equal sets? Two sets are said to be equal if they have the same number of elements and same elements. Like in this set, I have 1, 2, 3. In this 3, 2, 1. So these two are equal sets. And one important thing we should remember, in sets, order is not important. Suppose if A is equal to 1, 2, 3, 4, 5, we can write this as 2, 1, 3, 4, 5. Any order. You can write in any order. In sets, order is not important. In ordered pairs, we take the order, but in sets, while writing the elements, order is not important. So here, equal sets means if two sets are having the same number of elements and same elements, then we can say these two are equal sets. Here, equal sets. Same number of elements and same elements. So, can be in any order. They are the equal sets. The next one is finite and infinite sets. Finite and infinite. Here, finite means if the number of elements are countable, that is the finite set. Suppose the number of children in your class, a total number of people in India, In India, so many like more than 140 crores, but still we can count. That is the finite only. So what is infinite bit? Which you cannot count. Suppose if it is a set of natural numbers. Set of natural numbers, it is an infinite set. So that is the infinite set, because we can't say the exact number how many natural numbers are there. So it's infinite set. Finite means if the number of elements are countable, that is a finite set. Infinite which we cannot count, that is the infinite set. So next, cardinal number of a set. Cardinal number. What is this cardinal number? Cardinal number. Suppose if I take this 1, 2, 3, 4, 5, 6, 7, there are 7 elements. The number of elements of set A, the number of elements in set A, there are 7 elements. This is called the cardinal number. Cardinal number means the number of elements present in a set, that is called the cardinal number. So denoted by small n in bracket, number of elements of A. Here, what are the number of elements of a null set? Cardinal number of null set, that is 0. Number of phi is equal to 0. So for a finite set, we can say the number. If you take some finite set, that may be some x, you can say there are 100 elements or 50 elements, something. But if it is an infinite set, we can't say about that. It has no cardinal number. Cardinal number means the number of elements present in a set, that is called the cardinal number. Okay, so this is the basic information and definitions about the sets. Okay, so let us recap everything what we have discussed in this video. Set is a collection of well-defined objects. What is a well-defined? Well-defined means you should be able to identify whether the element is belongs to the set or not. And sets are denoted by capital letters, and elements, if you use the alphabet, we use the small letters, and the numbers, real numbers or whatever. And to say whether the element belongs to the set or not, we use the epsilon symbol. Epsilon means belongs to or does not belongs to. And sets can be represented in the roster form and set builder form. Roster form, we list all the elements of the set by separating the commas in braces bracket, that is the roster form. And builder form, in builder form we describe the general property of the elements by using that x such that x belongs to, x is an even number, like that we describe, that is the builder form. And types of set, if you see, null set. Null set means the set which has no elements, that is the null set and denoted by phi. And the universal set is if you take some particular issue, all the sets which contain as a subset, that is called the universal set related to that particular issue. And a subset means a set which is, suppose A is subset to B, means all the elements of A are elements of B, then we say A is subset to B and B is called superset to A. That is about subset and superset. And in subset to, we discussed phi is subset to all the sets, and every set is subset to itself. And so it's related to particular issue, all the sets which we are taken from the universal set. The universal set, all these are subsets to the universal set. Now equal sets means if two sets have the same elements and same number of elements, they are called equal sets. And finite and infinite. Finite means in a set, if the number of elements are countable, that is a finite set. If they are uncountable, that is a infinite set. And if the last thing is cardinal number. Cardinal number means the number of elements present in a set, that is called the cardinal number and denoted by number of A like. So if you take number of 5, that is 0. For finite sets, we can say the cardinal number because it has some number. But for infinite set, there is no cardinal number. Okay, this is the basic information about the sets. So in next video, we will discuss the operations on sets. Like operations means numbers we have like addition, subtraction, multiplication, all these things. In sets also we have operation like combining, separating, all these. Union, intersection, difference, finding the complement. These operations which are very, very important. So that we will discuss in the next video. Okay, viewers, once again, I request all of you to subscribe our channel and share the video if you think that is very helpful. Definitely you must share, like and comment also. And one more request, you must comment your doubts or whatever you wanted to learn. Please tell me through comments. Definitely I will explain all the concepts. Not only concepts, if you have a particular question which you can't understand, I will make a small video or short to explain that particular question. Okay children, bye.